Okay, so we're calculating torque here. Again, we're going to read the question, write down the important parts. A force of 20 newtons is being applied at the end of a wrench that has a 40 centimeter length. So let's assume usually wrench is working with some kind of bolt or nut. So here's our bolt. Here's our wrench around it. Okay, so here's our wrench. The force is being applied to this bolt here. The wrench itself, right, so let's give it just a two-dimensional length. The length of it is 40 centimeters. And it's being applied, the force is being applied. Excuse the arrow. Force being applied to this wrench is 20 newtons. Is being applied at an angle of 60 degrees. So if we're going to make our triangle here, we could say that is a 60-degree angle it's being applied at. Okay, but what's important is remember when we're calculating torque, our formula is the R cross F. So the radius or the length of the object cross the force being applied. And we're looking for the magnitude of that. Well, remember that formula is magnitude of our radius or length, magnitude of the force being applied, cos, nope, I lied, sine theta. Okay. Did I write cos in the last one? Yeah, I did, but that's okay. Oh, that's because that was that. Okay. The reason it is sine theta in this one, if you notice, is because when we're talking about these forces, our opposite side are forces of 20 newtons here. So, magnitude of our wrench. Our magnitude of our wrench is of 40. Now remember, this is 40 centimeters. Remember, these are being measured in meters. What is our force measured in? You remember? Newtons. Okay. So newtons, and our radius is being measured in meters. Well, because this is centimeters, how many meters is that? 0.4 meters. So our magnitude of vector R is 0.4. Our force being applied, oh, I did forget. No, that's okay. Our force, yes, our force being applied is 20 newtons. And our angle is at 60 degrees. Okay? So, when you go to put this all on your calculator, sine 60, what is sine 60? It's like 0.5. 60 sine, okay, times our 20 newtons of force multiplied by our 0.4 meters of length gives us a 6.9293 joules of torque. So 6.92, I'll leave that as a J, joules. Okay. So similar type ideas. One of them we're using the dot product. We're using the dot product to figure out work in terms of pulling an object. And while calculating torque, we're using our cross product of the same, roughly the same idea. We're using force in both instances. In one instance, we're doing distance traveled. In the other instance, we're kind of using the distance of the object we're turning. Okay?